Welcome to clickmyproject.com. Let me discuss about the project age estimation using a hierarchical classifier based on global and local facial features. Let me discuss about the abstract of the project. An age grouping system for grayscale facial pictures is proposed in this paper. The root of the system is divided into three phases: setting, feature extraction, and age ordering. Two geometric features and three wrinkle features from a facial image are then gained. The first one employs the geometric features to distinguish whether a facial image is a baby. If it is not, then the second network uses the wrinkle features to classify the images into one of three adult groups. The key issue of any classification system is how to find a set of reliable features as the basis for categorization. According to the studies of facial sketch and dramatic makeup, many facial features change the age increasing. These features could be divided into two categories: wrinkle features and geometric features. The sobal edge magnitudes approximating. The proposed shape structures represent embryonic patterns showing a common goods all over the image. LBP is a local texture machinist with low computational involvedness and low sensitivity changes in radiance. Also, HOG, Kaber, and geometric features are extracted, inspired by the dropout erudition techniques now popular with deep belief networks. Is applied here for keeping support vector machines to our facts. For the first time, the report wide-ranging test analyzing both the difficulty levels of present-day benchmarks as well as the aptitudes of our own system. Finally, the support vector regression has been implemented for recognize the exact age group of the persons. This process not based on the base paper work. Let me discuss about the flow diagram for our process. First, capture the input image from source file by using your getFile and immediate function. User can able to change the size of image by providing pixel height and width with the help of immediate function. Image pre-processing. Median filtering is a linear non-linear process useful in reducing impulsive or salt and pepper noise. It is also useful in preserving edges in images while reducing random noise. Impulsive or salt and pepper noise can occur due to random bit error in a communication channel. Next, in the gray conversion or distinct from one bit to black and white images, which is in the context of computer imaging or images with only two colors, black and white. Grayscale images have many shades of gray in between. Next, Sobel operator, sometimes called Sobel filter, is used in image processing, computer vision, particularly within edge detection algorithm. Scan edge detector also applies. Next, in the image enhancement, here histogram equalization is a method in image processing of contrast enhancement using the image histogram. This method usually increases the global contrast of many images, especially when the usable data of the image is represented by close contrast values. Next, contrast stretching, also used as a image enhancement technique. It is often called the normalization. It's a simple image enhancement technique that attempts to improve the contrast in an image by stretching the range of intensity values it contains to span a desired range of values. Next, in the image segmentation. Image segmentation is a process of partitioning a digital image into multiple segments. The goal of segmentation is to simplify or change the representation of an image into something that is more meaningful and easier to analyze. Next, in the feature extraction algorithm. Here, LBP features, that is local binary pattern, are proposed. Is divide examine window into cells. For each pixel in a cell, compare the pixels to each of its 8 neighbors. Next, HOG features are proposed. Histogram of oriented gradients is a feature descriptor used in the computer vision and image processing for the purpose of object detection. This technique counts occurrence. Gabor features are extracted. Gabor wavelet transform and its application. Wavelet transform could extract both the time, the spatial and frequency information from a given signal, and the tunable kernel size allows it to perform multi-resolution analysis. Finally, the geometric features are extracted. Geometric stretch measures the amount of spacing that occurs on the surface when the parameter domain is uniformly sampled. Next, these features are classified with the help of support vector machine and kernel nearest neighbor. Support vector machine, a multi-class SVM are proposed. It's a discriminant classifier formally defined by the separating hyperplane. Next, the K-NN classification. K-NN is a fundamental and simplest classification technique when there is a little or no prior knowledge about the distribution of the data. This would compare with the entire dataset and also the input feature values. The support vector machine and kernel nearest neighbor are classified. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right-click that file and run for executing this process. This is the main window for the human age classification. By pressing the input image button, we can browse the input image from the dataset folder. Select any one images from the dataset folder. Here I display the input image in the axis 1 plot. By pressing the gray conversion button, we can convert our color image into gray format. Here I display the gray image in the axis 2 plot. By pressing the noise removal button, we can remove the noise. This is the noise window, removal window. By pressing the median filter, we can perform the median filtering operation. Here I display the median filter result. By pressing the mean filter, we perform the average filter operation. Here I display the mean filter result. By pressing the next button, we can move on to the main window. By pressing the edge detection button, we can move on to the edge detection window. Here there are two processes performed, Sobel edge and also canny edge. By pressing the Sobel edge button, we can perform the Sobel edge result, and by pressing the canny edge button, we can estimate the canny edge image. By pressing the next button, we can come back to the main window. Here now we are going to perform the enhancement process. By pressing the image enhancement process button, we can come to the enhancement window. By pressing the histogram equalization button, we can equalize our image using histogram equalization. By pressing the contrast stretch button, we can perform the enhancement process with contrast stretching algorithm. Here I display the contrast stretch image. By pressing the next button, we can come back to the main window. Here we are going to perform the image segmentation. By pressing the image segmentation button, we can come to the segmentation window. By pressing the color segmentation, we can perform the color segmented image. Here these are the cluster region for every part of our input images. By pressing the gray thresh method, we can perform the gray threshold algorithm by using the calculating threshold value. By pressing the next button, we come back to the main window. By pressing the feature extraction button, we can perform the feature extraction value. Here this is the feature window. By pressing the LBP feature, we can estimate the local binary pattern for our input image. This is the feature values represented in the image, and this is the feature values. Here I displayed in a table format. By pressing the Gabor feature, it is Gabor wavelet algorithm. Here I display the Gabor feature in our image, and here I display the Gabor feature in a table format. By pressing the Gabor and LBP, here we perform the combined combination of Gabor and also LBP. Here I display the Gabor and LBP feature values. Now by pressing the HOG feature button, we can estimate the histogram of gradient values. This is the histogram of gradient values representation of our images, and here I display the values of the HOG feature in table format. By pressing the geometry feature, we can calculate the face parts. That is, here the facial part of our features value extracted, and this is the representation for and eye coordinates, mouth coordinates. These coordinates values are extracted, and here I display the geometry feature values in a word table format. By pressing the next button, we can come back to the main window. Finally, we classify the feature values with the entire data set. Pressing the classification, this is the classification window. By pressing the HTML classification, we got the result as age between 11 to 15. Also, for performing the KNN classification, we also got the age between of this persons. And by pressing the next button, we can move on to the analysis window. That is the prediction window. Here, the support vector regression button are used to estimate the exact age of that person. By pressing the support vector regression button, we can estimate the exact age of the person. Here I display the person in axis 1 plot, and this is the visualization of the trained SVR. Finally, by pressing the analysis button, we can estimate the accuracy, sensitivity and specificity of our existing and proposed system. Thank you.